So hello everyone, thanks for coming. My name is Zafar, so full name Zafarzhon, but don't mind that. I'm actually from Latvia, Riga, so neighbor, and I'm here with team. We are from Accenture, and about me, here the LinkedIn. If you are interested, you can go there, check. I'm partial data engineer and data scientist. So on today's topic, we'll discuss the hybrid approach of product matching, but it's actually also kind of text matching. You'll see how we implement. So you see the kind of final solution that we came up. So there won't be too much code. It's more the systems that we build up for one of our project. So what's going on there? We have a practical example when, for example, we need to gather precise information about the product that is selling. Yes, sometimes we can do inventorization, for example, in kind of small source, but let's imagine we have a large manufacturer. Let's say, for example, cheese, right? So you manufacture cheese, and for example, Remy or Maxima buying this cheese and they put their labels. And you sell this cheese to them by a bulking, so like in tons, maybe hundreds of kilograms. So but you don't know precise information like how much is actually being sold and how much is actually being, for example, just throwing out at expired. So this is the same situation. A product can be anything else, anything for e-commerce, right? So on print demand t-shirt that someone is doing. So the, let's say, manufacturer or just another company wants to know the precise data on it. Yeah, the simple example is the problem also can be that the iPhone, yeah, so in this case is X phone, in different countries is selling under the different names. So yes, there we all know that on the label it's selling like X phone, but if you go online, the name will be a little bit different. And when you ask the retailers to send their data to you, they will not care changing the name back to how you want to see it. They will say it. Sorry, they will send it back as just regular data that they store. So there's a bit messed up also with the language stuff, for example, in Japan. And let's move on to our practical example that we occurred. So we actually work with, yeah, guys, alcohol is bad, so don't consume it, etc. But we actually had a project with alcohol distribution company. And what they do, they produce alcohol all around the world, literally everywhere. And they have a lot of different brands, like maybe over 1,000 different brands. And yeah, and these some kind of popular brands selling under different naming, depends on the region or cultural reference. So for example, as we humans can say that these four products on the left side, so color vodka rosa, yellow vodka rosa, difference in naming, because for example this is how retailers can name it, yeah, on depending on their database class. So yel.vdk rosa, and the last one, the on the rightest from the left side, vodka rosso amarillo. Amarillo, it's yellow from Spanish, so just different name, right? So we can say that it can be related to our standardized manufacturer name as yellow vodka rosa. So yeah, matching is easy for human, but what about machines, guys? That's a problem. Yes, right now we have LLMs, but we'll come to it. But what the traditional way, how we used to do it, or how we most 80% of the time will use to do it. So we are using this kind of algorithms to do it. So has everyone ever tried to use this algorithm? Just yeah, and that's wrong because everyone have tried it. Even the simplest Control F when you do it in Chrome, it uses this naive approach. So everyone was common, but we have a problem here with these algorithms. How it will understand the New York and NYC reference, right? So for us humans, we know the context about that, but algorithms don't care. They don't see the pattern to match it. The same case stands for the multiple documents matching for TF IDF, for example, one of the algorithm that we also will use, but it's about that later. And NER, which also was mentioned in a previous talk just right now. So yes, across the multiple documents, we can again use the algorithms. But if we have example when we have, for example, one person with two different resumes, front-end developer, for example, but in one resume he mentioned the Vue.js, in another one it's React framework, and these algorithms would not think that they are the same person. However, it can be the same. So basically, we need LLM, definitely, guys, for that. We need to gather the context. So quickly about NLP and LLM, what the difference? Maybe someone here is not very into that. So NLP is a field. It includes LLM, and LLM it's specific models which uh, created to generate a text and understand maybe the context of it. So as example, we all know this GPT, Llama from Meta, it's of open source, and the BERT that we will use, it's from Google, and you will know about that a little bit later too. We'll come to that. So guys, but again, quickly to overview why we need to use algorithms, to be honest, most of the times. First of all, it's very fast, much faster than NLP, to be honest. Accuracy base, it's also pretty good. However, the crucial part, context understanding. Without that, poof, your work can be just nothing without this part. And we only need to use LLM if you really have enough resource. For example, we use Azure, and we were a big company, but it still was kind of costly. Even some managers said, like, can we somehow play with it, so like save some money. Yeah, but it is what it is. So about our project itself, again, this is what's our system that we built. So again, we have a source data. The source data is the retailers information that we gathered. Everything we saved into the data lake. It was Azure, but in your case, it can be something AWS, on-prem something. Also, we have the G list. It's a golden list, also as a standardized list of our product manufacturer names. So, sorry. So we of course needed to match it to compare it with. So if when we get the data, we see, did we already compared it before? Yes, everything is fine. It finds in the data lake. If no, the both parts, the source data and golden list, pass through matching engine, and there this black box decides whether it automatically matches it or it marks it as a human validation. So some kind of human, we also had that, need to check it. But overall, guys, I can say that our goal was to at least proceed 80% of data with accuracy 95%. So only 5% error rate we are accepted. And actually, we reached that goal, spoiler, but we'll come to that also. Just quickly about the source data and the technologies that we used. So source, again, there's 4 names referencing to one standardized name in the golden list. The technology, the warehouse was Azure. For ETL, LLT, and etc. Also for streaming, we use Spark. For stream, we use Kafka, and for orchestration, the everything we use Airflow. The data lake structure, the famous medallion architecture. We'll not go deeply into that. You can Google it. It's most everywhere, I think. Most of the time it's used like that. So we have bronze layer. It's a raw layer also called. In a silver layer, we clean up, transform data, so make it pretty for our business users, which then this pretty data we save in a gold layer. So now to the interesting part, the machine matching engine. What is that? So it consists of 5 steps: pre-processing, so clear the data, prepare it; matching engine, which is the matching algorithm. So it's a first algorithm just to exclude all easy cases which can be matched. If we have the hard cases where we need context, so the confidence score of the matching algorithm is low, we move it to LLM to work with that. Then we use a feature extraction, because the only opinions for the matching of the algorithm and LLM is not enough. LLM also not 100% reliable on. So we need another opinions. I'll show to you about later. And at the end, we have a final AI model which consumes all information and then decides. So do we need human or it's a good? We can pass the data. Let's get step into that. The main part where I'm going to break it down because I want you guys to understand what technologies we used, because I asked the permission, can we share it? And we could. Yeah, guys, corporate stuff. So processing, just basically the you know the not the same data become the same type. Everything good. For that we use the PySpark. So we're good with that. Now we move on to the matching algorithm. I hope you see it back good, yeah. So we used the TF-IDF. So basically, what is TF-IDF? Shortly, TF-IDF stands for, I don't know, but TF is for measuring how important the word in the document, and IDF is how rare is this word in the across all documents. So it finds out overall, gives us the understanding is how many times the words, how much important the words across all documents, and we'll use that information um, to to create the KNN model. So we put these TF-IDF vectors in the nearest neighbors. So the closest similar similar words will be located somewhere closer to each other, and to match the score we use this one minus distance of the nearest neighbors, and that's how we get these scores. So on the screen now, again, why would do that? TF-IDF plus n-grams plus KNN, because it's much actually faster. We tried it, and actually there is already open source library. You can see TF-IDF matcher in the pip library. You can check it there. So basically, we get first the first table where we get the first algorithm matches. So in some cases, for example, in the case of yellow vodka breeze and breeze yellow tropic vodka, that's the first ones, the matching score is pretty good. But the next one, breeze vodka, yellow vodka breeze, yeah, they kind of similar, but not so enough. And with the yellow vodka yellow Kariba, it's completely mismatching. Yeah. So again, with the good ones, we straight away match it into our database. With the bad ones, going to our Hugging Face, it's a BERT. So BERT comes from Hugging Face. That's why I was thinking what icon to use. So that's my decision was LLM. So we used BERT because BERT is very nice for context understanding. In the next test, I will explain why. But for now, just assume that we use BERT. What we actually did, we fine-tuned it a little bit. Then we created embeddings from our matching words. So for our resource words, source words, and for our lookup words. So imagine it that we have a map and we have a words family. So we need to correspond words on some locations, yes, so coordinates. So as machines don't understand the text, we need to make them the numbers. So let's imagine we have a word family, somehow translate it to the digits. So we point it in some kind of map. And then we have some words like a dad, mother, sister, brother. They all will be located pretty close to each other, but vice versa if we take a word penguin, right? So penguin will be far away, and of course it will not be closest to them, and it will not count as a match. So basically we did actually like that. And for calculating the similarity, the closeness, we use the cosine similarity function, and we got result that you see on the screen. And now about the, for example, why not the GPT, right, guys? So actually BERT was designed by beforehand that it should understand this semantic search. It good at semantic search. It was designed for that, and good for text matching. So and most important that BERT model type is bidirectional, So it's not like a ChatGPT when you type something and generate, it goes from left to right. No, BERT is more like to fulfill some kind of missing words in the sentence. So that's a good part of it. Our a little bit just technical part, the how we trained it. Actually, we didn't have a lot of data. It was very painful in one place to match them together manually. So we hired a team to do it. They only spent 1 month on it, so we got only 8K of manually labeled records. For the model name from the Hugging Face is BERT, multilingual, of course, because models from across the region, products come with different names, as I said. As we have so small records, guys, I really recommend just to train maybe last or last two, maybe last 3 layers, depends on your case. In our case, the best results was if we freeze just last two layers. If we train only last two layers, and everything was maintained and deployed in Azure Machine Learning Studio. Next one, feature extraction. What I said before. So imagine that we gathering opinions from five different algorithms LLM. So TF-IDF thinks that match between color vodka breeze and breeze yellow tropic vodka is 77%. BERT thinks it's 80%, but 2 is not enough. We also use the word count difference, like a small function to see how many words in the first and the second. Then Levenstein distance, it's another function, also more popular. It measures, I think, if I'm not wrong, it's how many actions do we need to change the word so it's becomes the same as the looking up the word that we are looking. And fast text is basically library, embedding library from the Meta open source. Also, it supports different languages, so it was pretty useful. So in the case, for example, we have after feature extraction, we have 5 opinions from different algorithms, and now we need to finally make a decision. Do we save it or we mark it as a human validation required? This is what we do. Unfortunately, for the binary classification model, which do the decision, I cannot uncensor it what directly inside, but it's simple deep learning model with couple of basic layers, and at the end, so I can characterize it as a binary classification model if it makes sense for you. You can find a lot of examples in the internet, so just use the one that's it's mostly good for you. And good, we are about on time, guys. So about the overall conclusion, we saw our case, how we did it. If you are in e-commerce or also in some kind of manufactured product business and you need to gather the precise data and you have struggling with that and you need also to do this kind of matching procedure, you can try to use our methods, but of course up to you. You'll need maybe to change the LLM because this project was 2 years ago, before ChatGPT become a little bit smarter than now. So yeah, and choose wisely. Have the more label data you have for fine-tuning, better, because like the perfect should be more than 10,000, at least 50,000 labeled. It should be. Then you can retrain whole model. Then you can fine-tune the whole model up to your case. If you're gonna use the open source models, but we also tried the OpenAI. They also have a text embedding, but at that time it was so expensive, guys. Maybe now it's cheaper, I didn't check, but we tried. It was good, but it was very expensive. So basically, yeah, like that. Do it yourself, as you know, guys, and your solution always can be better. As says the Buzz Lightyear, beyond can be reached or something like that. But you know, from Toy Story, yeah. To infinity and beyond, exactly. Yeah, guys. So thank you very much. That's it. My LinkedIn, guys, if you want something. Any questions?
Hi, thank you. So, what was the scale of this project? That is, how many product listings and how many languages?
That's a good question. If I'm not wrong, first we start with the Europe. In Europe, you already know Portuguese, Spanish, everything else. So it was around 50 languages, and the scale. Um, so it was around a couple of millions products gathering from all around this Europe retailer stores. You know, like alcohol usually sells in these stores, so they all call them as they design these names. So it was the tricky part, actually, to be honest. That's what with this case, with we had a couple of sources where they don't have uh, they provide vodka, VDK, whiskey without some K words. So that was the main problem. We even tried to remove all vowels from all sources. Actually, we got good scores, but at the end we decided no, we don't want to follow this.
And
Yeah.
thank you. Another question. How did you define a unique product? Because sometimes the lines can be a bit blurry. For instance, I don't know, Coca-Cola from one country and from another, sometimes they're different. So did you have any problems there? And how did you define it in the end?
Uh, Duck. Okay. Okay. You mean how how did we try to separate, right, these products from our manufacturer name?
So
How we
what's the definition of a unique product? So sometimes there might be subtle differences. Just
yes, if they're not unique. Uh, you mean from sources or from our
so
manufacturer?
what's the definition of a product? I can
Okay,
ask you
okay, okay, okay.
after if it's a
So
complex question.
manufacturer already provided us these unique products. I don't know how they did that. It wasn't my like business, but they already did. Our job was to define this uniqueness in the source, and how we did that. It depends only from the source. But for example, we have Rimi Maxima. If the same name comes from the Rimi and Maxima, we don't say that they are unique because they are from different sources. But we all still matching them to one single source from the manufacturer. Yeah.
With human feedback in the loop, are you also retraining the BERT model?
That's a good question. Yes, it was after I already was not part of that project, but yes, they collected more data with human validation and they retrained it. We actually made a schedule, like every week it was checking the accuracy level, how it was moving, because sometimes just new source data can connect and it was completely out of our expectations, right? New data. So yes, of course, it was every week it was just retrained to stay on level, and with the new data every month it was trying to exceed its previous like best point. That's true. Yeah. Sorry, actually in Azure, no, you can pass. In Azure, it's very good because they automatically have a tool to do that. Just saying.
Yeah. Do you only use text-based data sources, or maybe you use image matching or something?
No, it was only text because source providing only text. No.
Hi.
Hello.
You mentioned the G list. What kind of the information could be kept in the G list? It's more product descriptions, or what could be in those lists?
It can be anything that you defined as what you want to match for. It can be in our case it was product names and the volume of the bottle, and something like a unique identifier of the from the manufacturer, right? Something like that. But in your case, if you would also want to look into the description of the product, yeah, for example, you have a product and you want to match not only from the product name but only like the description of the product, it also can be included there. It doesn't matter. But again, if you have a lot of text in the description, LLMs are slow right now, and creating embeddings takes some time. That's why we first use the algorithms, just the basics one, then we use LLM for the hard case. Yes?
Yeah, we have a really active audience.
That's nice. That's very
Yeah,
good.
sadly we do not have time for more questions. If you have them, please contact
Discord guys.
Yeah.
Or yeah, better to be honest, if you want to contact me personally. I don't like Discord. That's my opinion. Sorry for that. Use my LinkedIn. Yeah, that's it. Okay.
Yeah, and we ask you to put the slides into in the Discord channel.
Okay, I'll do it.
Thank you. Thank you.
I might forget. Yeah. Thank you.